Guys, welcome to FEA practical session. So this is session 4. Previously we completed 3 problems on different types of bar, that is a uniform cross-sectional area, then taper bar, and after that a step bar with different material. So in today's session we will start with stresses. So this is a problem 1 for stresses. Previously we used units in mm. Now here you can say the area and lengths are in meter. So Abaqus basically follows the certain group of units. If you use SI meter, SI mm, then you have to follow the units accordingly. You can't interchange the unit. So for current problem, we'll go with SI meter. Okay. So length will be in meters. Stresses, Young's modulus will be in Pascal. That is Newton per meter square. So for 210 GPa, it will become 210 e raised to, that is 10 raised to 9 Pascal, Newton per meter square. Let's start with the problem. So we'll create first part, 2D planar. This is truss, wireframe. So length is 4 meter. So we'll take approximate 10 meter area. And we'll begin with our part. Okay, click on line. Now this time I'll specify the coordinates. Check on these bottom parts. Okay, x coordinates and y coordinates for starting. So I'll say from origin 0, 0. Enter. So I get the starting point. So length of my first truss is 4 meters. So I'll write 4, 0. Okay. So my length is created. Right. Then height is 3 meter. So y is 4 and x is 4 and y is 3. Enter. Then again here. So here x is 0 and y is 3. So type it here, x is 0, y is 3, and so it is created. Escape. One more member is there which connects starting point in this lengths. Okay, 4 meter, enter, and this height is 3 meter. So the problem is created. Basic. Let's create this part, close the sketching and select done. Go to properties, create properties, material, elastic property. Now we need in Pascal. So 210 e raised to 09. Okay, in Young's modulus it becomes 2.0. You can save this property. See, go to material library, then material library manager, create, say, FEA materials. FEA materials. Save. Okay, it is not taking dash for underscore. Okay, then just select this material and add it. So you can add different material in your library and save it. So you can use it for another time. There is no need to create new material every time. Okay, close this and you can just go to your material library, that is FEM materials, double click it and the material will be added into your model. Right, let's create the section. Okay, section 1, truss beam, continue. So cross-sectional area is given, that is 0.1 meter square. 0.1. Okay, so assign this area now. See, Section is created. Assign it to the entire model. Done. Select the section. Continue. Okay, this is done. Let's go to assembly, create assembly. Okay, see it started from origin. Then go to step. No need for create a step. Static. Linear bit division. Continue. This is a loading step, right? Loading. Okay. Then go for mesh first. First of all, select element type. Select entire model. Okay. Go for truss. Click on. Okay. Now go to meshing seed size. Seed by edges 1, 2, 3, 4. Okay. So I'll first select this one. Okay. I need only single element for that section. So I'll select 1. Apply. Okay. For this one then again 1. Apply. Okay. For this one select, apply, and then okay, and then last apply. So this is done. Mesh sheet. Yes, meshed apart. So meshing is completed. You can check. Query mesh. Total 4 nodes. 1, 2, 3, 4. Then 4 elements. 1, 2, 3, and 4. Okay. Type is also mentioned T2, D3. That is truss element 2 planar 2. Close it. Go to loading. First of all, we have to fix this 2 point, then we have to apply 2500 Newton vertically downward, and then 2000 Newton away from origin. So load, concentrated force, continue, select this point, click on done. So on this point, if you check the sum, load is acting vertically downward, that is 2500 Newton acting downward. Downward direction is in Y, that is second axis downward, that's why we are putting negative Newton, right? Okay. Then loading, concentrated force, second load at this node, it is acting in same direction as X, so that is 2000 Newton. Okay, let's fix these 2 points. Okay, and caster, continue, select this one, then shift and select second point, click on done and casted. Okay, so this is done. We applied the boundary conditions. Let's go for solution. Create a job. So this is a problem number 2.1. Continue, click on OK, check the data. Okay, check it's completed. There is no error. Submit it for analysis. Monitor it. So it is completed. Dismiss. Go to results. Okay, click on plot contours on deformed shape. You can change the contour density. Apply. Okay, click on it. Now, what is happening here? Anyone? See, we keep this end free. We need to apply some restriction. Why? Because there is a roller support, right? So roller support only allows movement in X direction. There is no movement in Y direction. Let's see how to implement. Go to load again and then go to create boundary condition, right? So create boundary condition, that is displacement. We have to restrict the degree of freedom in X We have to allow in x and we have to restrict in y direction. So select displacement, continue, select this same point, click on done. So we need only movement in x or displacement in x direction. We just allow this x to be free and other degrees we will restrict. That is y will keep it 0 and rotation along z we will make it 0. Okay, so only x direction is free. Again, go to your job. First of all, go to feature and regenerate it. And go to job, edit it, and now again submit it. Okay, it is completed. Close, go to result. Now check the results. Clear? Now this is not moving down because we restricted. That's y direction we restrict. Now you can check the results from here. U clear? That is in meter. 10 is to minus. Okay, that is S, which is risk at different point, and then reaction process. You can plot these properties, displacement, stress, reaction force at different node by using plotting options. Go to chart. Okay, then OBD field output, continue, select unique node. Okay, then if you need displacement, select displacement, and let's select the node. So edit selection, this node is selected, and plot it. This is the point here. This is the displacement. You can import this data also to check the values. Current plot. Okay. Clear? So final this. Okay, similarly you can plot for stresses, reaction force. If you are having any doubts, kindly comment or you can contact me on my WhatsApp number. Thanks for watching the video.